Hi folks, Carlton from the Pharmacy Seeds Network. Just wanted to go over thermal mass and greenhouses a little bit. I know my friend Josh from the Citystead, also here on YouTube, I'll put a link below, has a greenhouse, and he's been experimenting with using thermal mass to store heat, and he's had some success with that, but he's found out how difficult it is. I started out with a similar concept in mind, and I found out just how much heat you had to add to it as well. We're both at similar latitudes. He's in Michigan, I'm in New York. I'm at 42 north. I don't know his exact latitude, but just thought I would do a quick demonstration video here using the Greenhouse Raspberry Pi 4 to kind of go over how much heat you actually need to keep a greenhouse in comfortable temperature ranges for plants. So the chart we're looking at here is the last 3 days of the greenhouse. And yesterday we had a nice warm day, as you can see by the chart. And last night it stayed relatively warm, so I did not start the greenhouse furnace up, in part because we didn't necessarily need to, and also in part to do this video as a demonstration. So let's just start up top here. BTU total is obviously the total number of BTUs in storage in all the thermal mass tanks that are being monitored in the greenhouse. When I say BTU total, that's referencing 60 degrees Fahrenheit as basically what would be 0 BTUs in a tank of water. The BTU store with the blue line here is that large 275 gallon tote. BTU stored 2B, this reddish mauve purplish line there, is the 100 gallon tank to the left of the stove, and BTU 3 is the large stainless steel pot on top of the stove. Then down here, stove is the line in red. Thermal mass is average temperature of the big 275 gallon tote. Outside is obviously outside temperature. AVGH or AVGGH is obviously average greenhouse temperature, and hot 3 is that pot on top of the stove again in temperature rather than BTU. So you can see we had a relatively cool night. Here we go. A relatively cool night. The previous night to yesterday, we're down to 40 degrees, and you can see I had the stove run here relatively heavily, and we reached a little over 160 degrees in that thermal mass on top of the stove, and you can see that energy reflected here in the line up here. And then as the day went on, you can see the vents coming on with the jagged lines, and so that's heat being gassed off because the sun is out and it's too warm in the greenhouse, and we have to release some of that heat. We don't have a way to pump that heat off somewhere else to store it because that's complex from a technical standpoint. And then you can see the thermal mass take on some temperature at the end of the day. When I start the stove back up, you can see because it wasn't expected to be quite as cold out, and also because I had other things going on, it ended up not running as much heat into that big tank on top of the stove. You can see it held reasonable temperatures throughout the night. We never really went under 67. That's a nice comfortable temperature for the plants I have in there. And then you can see the vents come back on yesterday, the hot day that we had, and then you can see as the day goes on, more heat bleeds off of that thermal mass, and then as we go into the nighttime here and outside temperatures drop, even though it's still relatively warm out, we did go down to 50 degrees overnight, and you can see the greenhouse fell down to about 61 degrees overnight, and that hot pot on top of the stove was down to 83 with very little thermal mass in storage. We had a little burst of sun today. You can see that here in this temperature spike, and then relatively stable throughout the day. It was mostly cloudy, not super cold out, as you can see. We were sitting around 55 degrees or so today. It was a little windy, so we were losing a little more heat to that. But then tonight, It's forecasted to go down to, I think it was 38 or something like that. You can see here we've already dipped down to 38, and you can see we're maintaining a relatively steady temperature in the greenhouse, only because the stove was lit back up. And you can see I lit that stove up real hot when I did it, and you can see this the hot 3, the big pot on top of the stove's thermal temperature climbed dramatically, and that's reflected up here in BTUs and storage. So I just thought I would kind of give a demonstration of BTUs and thermal mass and that kind of stuff, so people have a better understanding. A lot of people think, that it's kind of like heating a room in a greenhouse, but the reality is, in a room you have insulated walls with good insulation. That makes a massive difference. In a greenhouse, we have plastic covering, single or double layer. Obviously double performs better, but you still don't have much of an R value at all, so you're losing a tremendous amount of heat. And so you can imagine in November, December, January, February, and March here, just how fast we lose heat. And so that's why we have to stay on top of keeping the greenhouse stoked up, keeping temperatures stable, so our plants stay comfortable. We don't lose anything to freezing or just cold damage. So just thought I would go over this quickly and kind of explain it to people and share it. I hope you found this interesting or informative. I hope you'll share this with someone else if you know someone who might find it interesting. And I thank you for watching the Pharmacy Seeds Network.